Hello, hi everyone. Let's get started. Okay, oh, hold on, I forgot to put in my headphones. Peace. Okay, so let's get started. Um, Again, hopefully for these videos, you are either doing them alongside me. I really prefer if you do this, like, are you attempted most of this on your own, and then you watch the video, but let's just see where we go. Okay, so let's see. Consider f of x to be 1 over x minus 3 squared. Write the limit of this function as x goes to 3 and evaluate the limits. Okay, well, technically speaking, right? Notation wise, it's this. And then we learned that with these sort of expressions where they are the same from our 1.1 section, and then this is even, that this will go towards positive infinity. Does f of x have a vertical asymptote? If so, what is it? So because of this rule, it does have a vertical asymptote, yes. And it is that x is equal to 3. Okay. To explain in words what's the limit as x goes towards -1 from the right of f of x equal to 4. Okay, so that I kind of just said it when I read the equation, but let me just go ahead and give you something. Um, the limit of f of x as x goes to -1 from the right is 4. Okay. Explain the word in words what it means for the limit as x goes to c if f of x exists. So that means that uh if the limit as x goes to c of f of x exists, then the limit as x goes towards c from the left of f of x and the limit as x goes towards c from the right of f of x match. Or something like that. Must exist and be equal or equal, something like that. Okay. Next one, use the graph to answer your following. So this is f of x. Let's see what we got. Okay, -4. Okay, this one's tricky because technically you can just right away see that it could be -2, but -4 doesn't exist. There's nothing from the left of it, so actually this does not exist. If it said -4 from the right, that would be what, -2, but it says there's no direction, so you have to check both. As x goes towards -1 from the left and the right, well, okay, that also has a thing where from the left it's -2, but from the right, it's -1. Those don't match. Does not exist. Um, as x goes towards 2, it doesn't exist from it does exist from the left, but does not exist from the right. So therefore, it does not exist. X goes towards 3, similar beef. It does not exist on the left. And as x goes towards infinity, we can just see that that goes towards infinity as well. Okay. All right. Next one. Okay, are the following limits correct? Okay, so let's see. So first off, we have the idea that as x goes to -2, that this is supposed to equal 5 over 2. Well, let's just do our substitution and plug everything in. We got -2 squared minus -2 minus 6 over -2 squared plus 6 times -2 plus 8. We have 4 plus 4 minus 6 over, wait, I don't know why I did plus 4. Negative times a negative. That's going to be plus 2, not plus 4, silly. Okay. And then the bottom is going to be 4 minus 12 plus 8. Okay, so I can see what's happening here. That's going to be 0 over 0, which does not work. Sad face. But we know that that must mean that -2 is a limit of, is a root of both of those guys. So that's what I'm going to do. I'm going to factor out x plus 2 from both of those. Let's do x squared minus x minus 6. We'll do x first, -3x minus 6, and then -3. Yeah, okay, that'll check out. And then over here, x squared plus 6x plus 8, x plus 2x, we got x squared plus 2x, minus we get 4x or plus 8. Times 4, that will indeed match. So I get x plus 2 times x minus 3 on the top, and then x plus 2, x plus 4 on the bottom. That cancels out. We get x minus 3 over x plus 4. Now we plug in -2, and we get -5 over 2, which is okay. So that just didn't have a negative, so it was not correct. Nope. And the limit was actually -5 over 2. Over here, this one's saying the limit as x goes to 9 is 3. So let's talk about that. Okay, so first we plug this in. We get 9 minus 9 over square root of 9 minus 3. Okay, that's definitely going to be 0. I'll do it in steps. 3 minus 3, which is 0 over 0. Okay, so that's not going to work. But I could definitely do the conjugate on the bottom to mess with it a little bit. So I have x minus 9 square root of x minus 3 with the conjugate. So x plus 3 square root of x plus 3. I'm going to leave it as a factor. And I get x minus 9. Oh, that'll cancel out. And you're left with square root of x plus 3. Now you plug it in and you get square root of 9 plus 3, which is just going to be 6. And then again, that's not the correct answer. All right. Hopefully our answers are matching so far. Last, number 6. Number 6. So answer the following about limits of infinity. Why is the limit of a bottom-heavy function 0? So this is actually more of a I said it sort of okay, I didn't really say it, I think. I kind of intend this to be more of like a talking point. So this is probably better to discuss, as a visual cue a little bit, but as a logical cue more specifically is what I want you to see. So the idea for the bottom heavy function being 0, and we kind of did see it with the power limit theorem, was that if the bottom part's power is heavier, right? That means, or is it's bottom heavy, right? The denominator's degree is higher. Then that means that the number will increasingly be bigger faster on the bottom than the top. And if you take, a smaller number divided by a bigger number, and you repeat that process to where the distance between them two makes it to where numerator is really tiny, but the denominator is really huge, well then that's going to be a number approximate to 0. So because of that logic, let me write it like this. Because fractions get smaller when denominator values get bigger. Okay. Why is the top heavy function infinity? Similar vibe. The gimmick here is that, regardless of how much the denominator is increasing, if the numerator is increasing at a faster rate, which if it's at a higher degree, given that it's top heavy, it would be, then that means that it's going to keep increasing, and no matter what you actually divide it by, it's still just going to keep going towards infinity. The bigger the numerator, the value gets bigger. Or I should have said, the bigger the numerator, the bigger the value. Um, so yeah, that's pretty much it, guys. Make sure you do your Cengage homeworks, because I know that I put a couple of challenging questions there, because I really want you to think about these limit problems, and I want you to practice this stuff. All right. Please let me know if you guys have any questions. Like I kind of said in the previous video, it's kind of awkward because I'm just posting these videos to the ether, and I'm hoping you all see them and respond to them and tell me what you like, what you don't like. If I need to redo a video on something, just let me know, please. Okay? All right. Wish you the best. Have a good one, guys. I will see you on the next one. Bye bye.